Yeah, I got carried away. Hold on. I got carried away. Day 10. Close all these out. Yeah, it is day 10. It's up. I've got distracted by doing other things. It's released. We're like a minute behind. But anyways, patch in the Autocraft's data port to discover weather forecast of a massive tropical storm before you can figure out whether it will impact your vacation plans. However, your device until shut turns off. Its battery is dead. You need to plug it in. The only problem is the charging outlet near your seat produces the wrong number of jolts. Always prepared. You make a list of all the voltage adapters in your bag. Each voltage adapter is rated for a specific output voltage. Puzzle inputs. Any given adapter can take input of 1, 2, or 3 jolts lower than its rating and still produce its rated output voltage. In addition, your device has a built-in voltage adapter rated for 3 jolts higher than your highest rated adapter in your bag. List where your device's built-in adapter would be rated for 12 jolts. Your device has a built-in jolt adapter rated for 3 jolts higher than your highest rate. Okay. Treat the charging outlet near your seat as having an effective voltage rating of 0. Enigma, thank you for the subman. Since you have some time to kill, you might as well test all of your adapters. Once you want to get your result res, you can't even charge the device. If you use every adapter in your bag at once, what is the distribution of voltage differences between the charging outlet, the adapters, and your device? Those are mega adapters of the following voltages. Your device's built-in voltage adapter would need to be rating for 19 plus 3 higher than the highest rated adapter. To a source 1 3 jolts lower than its rating. To use every adapter, you need to choose them like this. The charging outlet has an effective 0 jolts, so the only adapters that could connect to it directly would be 1, 2, or 3 jolts. Of these, only one of yours is adapter rated 1. Or 4. Your folded their adapters 5, 6, and 7. The valid choices, however, in order not to skip any adapters, you have to pick the adapter 5. Is one of 10 jolts. When you use every adapter, there are 7 differences of 1 jolt and 5 differences of 3. Here's a larger example. Okay, find a chain that uses all of your adapters to connect the charging outlet to your device's built-in adapter and count the voltage differences between the 1 jolt differences, multiply the number of 3 jolt. Okay, this is going to be kind of confusing to me. Okay, I'm like sort of confused, but maybe not. So what we need to first do, let's just take our list. Let's just do input and let's just do a sort real quick. Like literally, let's just do a sort. And then if I do a system out print line inputs to array, let me just quickly output this. I think this is what I want. Arrays to two string. Okay. Right? Oh, nope, this is gonna run the wrong day. Hold on. Hold on, chat. Oh, this is going to do this. Oh, I broke all of this because... Yeah. Okay, day 9. Comment day now entirely. Okay. On day 10, not day 9. I got carried away with doing all this stuff. Okay, we do need to map these. Luckily, like I literally right before this just did a mapping to integers. So I can actually use this method here that I literally just made. And I can just do a list of integers. And I can do input. I can put input strs here. And I can do equals convert to that, input strs. And I can do this one. And I can do integer compared to. Okay, so this one should sort it correctly, right? Oh, integer. Cool, so now it's sort of correct. So now we need to go through, we need to figure out how many 1 jumps there are. Okay, so for int So we just need to go to the next one. Basically, we need to find the differences between each of them. I equals 1, I is less than inputs. I think this is what it is. Size. Sub-MJR. I gotta at least start because I was not thinking of this. Okay. So we'll go through each of our inputs, and what we can do is we'll get our inputs, get I minus 1, and we're going to do int diff. I think it's just the diff between each line. Minus inputs get I. I think that's just all it's asking for. Okay, and then we can just do an int 1 diff, or a diff 1, and we can do int diff 3 as 0. So diff 1 here, we're going to do a check if diff equals 1, diff 1 plus plus, else else if in this case diff is 3, diff 3. I think that's all it's asking for, and I can just do an output diff 1. Is that what it's asking for? Whoops. Zero and 0, nice. That doesn't seem right to me. Because I'm going backwards. It should be the higher minus the lower. I keep doing this. Sorry. Diff 1 plus that plus diff 3. Okay. Now what am I getting? Getting 69 and 26. So if I go with there, not that. If I go with there, example inputs, just because I want to make sure I get this right first. There are 22 and 10. I'm off by 1. What? So there's 7 and 5. I'm off by 1 on both. Okay, we're gonna go on by the off by 1 method, and we're just going to call it that. So copy this. I like my classic, it's off by 1, so we're just going to add 1 to each of these. Okay, so we're gonna start them at 1. That's our solution here. And what we're gonna do is we're going to do lap, and we're going to pass in diff 1 times diff 3. And that should be our answer for part 1 at least. 1890. Hey, we got a gold star, nice. So there's part 1 done. I was really slow, but part 1's there. All right, part 2, to completely determine whether you have enough adapters, you need to figure out how many different ways they can be arranged. For every arrangement, needs to connect the charging outlets to your device. Previous rules when adapted still apply. For example, the only one that starts with 16, 10, 15 supports the following arrangements. Okay. The charging outlet in your device's built-in adapters are shown in parentheses given the adapters from the first example. The total number of arrangements connected is 8. Okay. Okay, you glance down back to back and remember why you brought so many adapters. It must be more than a trillion valid ways to arrange. What is the total number of distinct ways you can arrange the adapters to connect to the charging outlet on your device? So I'm feeling like brute force is not what you're supposed to do here. Oh, I think it's because you start at 0. I think that's 1. Okay. Oh, it's because you need to. Oh, wait. Did I figure out why this is off? It's because we need to do sort when you inputs add index 0, we need to add a 0, and then inputs add inputs get inputs dot size -1 plus 3. I think that is why that's off by 1 every time. There we go. Okay, so that's why it's off by 1 every time. We didn't add those in. Okay, so what? Part 2. So the way I was gonna do is just brute force, but I'm guessing you're not supposed to do brute force. To where you start and you kind of just tree out from there. Distinct arrangements. Well, we're going to do the brute force way. So, okay. So what we're going to do here is we're going to do, it's going to call, we're going to make a method here. So public void, or public int get arrangements. And so what we're going to do is it's going to take in the list of integers. And it's going to be inputs. And so what it's going to do is basically we're going to do so int arrangements is going to start at 0. And basically you're going to start at 0 here. You're going to start at 0 and you're going to go while the one you're at can still be plugged in, you're going to then branch from there. So for one iteration, it's going to be so int index equals 0. So it's going to be actually a do while inputs dot get index minus current is 0. So while map minus is less than 4, we're going to actually, it's not do while, it's just a straight up while. So while it's true, first thing we're gonna do is go index plus plus, and then arrangements plus plus. Arrangements is gonna be equal to get arrangements for inputs. Is there like a sublist from index to inputs? Whoops. Size -1. Okay, there's that. So that's going to be then our arrangements getting added on. And then current's this. So what this is going to need, this is going to take in current to make it a recursive loop. We're going to take in current here. We're going to need to move all of these into here. So it's actually going to start at 1. That way we don't have to do this. I think. I think. And it's going to need to be current there. Current is our number we're at. So it's actually not going to be this. Current's going to be inputs get index. So to do this, it's going to be get arrangements for current, which is going to be inputs dot get 0 with inputs. I guess we don't need this because current can just be inputs So we don't need current there. So where are we removing from this? Because right now this is going to be infinite loop. Oh, sorry. So this is where we're kind of going one less, but... And we're going to return arrangements. So this infinite loop is okay. Or not infinite loop, this is kind of okay. This recursive loop's okay. So we want... Current is the one we're sitting at. And so we're not changing current at all in here. So next is starting at 0. So we actually want to do remove here. So we're going to remove it. So now we have inputs is the correct size with index starting at 0. And so it's not a sublist. It's literally... Oh, it is going to be a sublist. Okay. Inputs dot size is greater than index. YOLO, let's run this. Just let's make sure, see if we get any errors. Probably get an error, right? Yeah. So now we're at the part where we're from index is a 1, but our to index is 0. So there's no more. So assuming that inputs dot size is greater than 0, greater than 1. Only 46. That's not right. What's going on? Okay, what is... So for this one, what we're supposed to get... Oh, we need to... That's why we're removing it. It actually started at 1. Okay, let's see if that fixes that. Input that size is greater than... So it's gonna be back to this issue again. So we can just do if... is it... If inputs dot size equals 0, just return 0. So the from index is 3, but there's a 2. Inputs dot size minus 1. 322, is that right? Nope. This might be where this might fall apart here. This one I'm not. My infinite recursive loop is not working like it should. Because the sublist... Why are we getting such a small number? Why are we getting such a small number? There's gotta be a better way to do this. Like there's 0.3. There's like there's gotta be there's gotta be some sort of math like reasoning I'm missing here. I just don't know the math behind what you're supposed to do. Because there's 19,000 possible. So what am I doing wrong here that I'm getting such a small number? $33. Oh. So current is that, so we pull that out of current. And then inputs get index as current is less than 4. I gotta be doing something wrong here. Why is this always going down by... Next plus plus. I'm doing the next plus plus too soon. Okay, I'm up higher, but still not nearly high enough. How many are in here? There's 31, so there should be 33 to start. Wait, is this exclusive? Oh, that's exclusive. That's gonna throw an error, right? Oh. Well, okay, well, there's that now. So now we're, okay. So now I'm way above what this is. So there's 19,208 of these, and I'm at like that much. So that's a problem. So from 1 to the rest of this, is there a sublist that's not an end? No. Yeah, so it's exclusive. Okay. So, oh no. Current is that. We start an index of 1, that way we're ignoring the beginning here. So this should not be needed anymore, right? Right, okay, so that's not needed anymore, right. It's less than 4. Is this gonna throw an error if I just do this? Yeah, okay, that's what I thought. Input size, index, that's right. So why are we getting... Is it these? But then there's no way for arrangements to increment. So if the arrangement starts at 1, because we get to here, it's an arrangement. Oh wait. Arrangement starts at 0. And then we check, right before this we check if inputs.size equals 1, return 1 here. Sorry, I started the arrangement incorrectly. So index of size of 2. Okay, so we do need what I just, oops, so we get rid of that. Copy that, so we do need this on here. Keep this same, but we do need that. And we got 0. Is it just that? Am I stopping too early? We got it. We got it. Wait. I found it. Hold on. I think we got it. Yeah, this is going to run a while. This is going to take a while. Yeah, so there's... Whenever you get to this, whenever you're running on... Especially on a desktop like this, whenever you're running for more than a second or two, you know you're missing something. I'm missing something. I don't know what it is. I don't know if there's some sort of... I mean, there's some sort of sneak math to this. I just don't know it. So... Oh, no. I don't know if caching here might speed things up. I don't want to stop it, but it's running for a while, so I can keep going. So I think one improvement we can make is having a cache on this. I don't know if there's a way for me to have a cache. Yeah. Actually, there might be. So let me try and do a... Oh. Alright, well, stream went down. I'm still recording, so... Ignore the stream's crashed, but okay. Private... So we can have a cache. So let me do a private static integer here. Still running. So in theory, this does work. It's just really slow. So let me have this cache here. And what we'll do is actually we can't initialize it there. I broke my CPU, they say. So now we can initialize the cache here. And so what we can do is whenever we get this back, okay, reconnect the streams back up. So we have a list of integers here, and so this is going to be the sublist equal to that. So we're gonna get this, okay. So sublist is that. We need this cache to not be int, it's gotta be a map of string to integers. We're gonna convert this basically the array here to that. So it's gonna be a hash map here. Okay, and so we're gonna do cache put arrays dot toString of sublist to array. And so this is how we're going to int sub arrangements. I'm just hoping that this caching is enough to do this. Okay, so all to do there, and then all we need to do now is just check if the cache has it. So as soon as we get to here, we can do a check if actually we need to do sublist there. We can do a string sublist string. So all we gotta do is check if this cache contains this sublist string. If it does, arrangements plus equals cache get sublist string. Otherwise, do it this way. Okay. Fingers crossed this somehow makes this faster. I don't have much hope. Or it could make it insanely faster. No way. Don't tell me that it actually worked. That number sounds about right too. If it ever lets me input. It's not right. Okay, let's go back. Let's test it with the shorter one. Let's just verify that this works. I get 19. I do. Let's just make sure it's not an issue with it wanting to be a long. I don't think this is the issue, but so 19202. Oh, maybe it was a long. Maybe it was I was trying to use not a long. I got a lot bigger answer now. Hey, it was right. Wow. That caching does that much? It goes from taking probably hours to a few milliseconds by just caching those results. Dang. All right. I mean, I thought the caching would help, but I still thought it'd take like a minute or a few seconds, not milliseconds. Wow. Okay, well, that's day 10. Let's go through. I can try and explain what this is now that I better understand it a little bit. Yeah, I definitely clutched. Actually, how did I do? I probably did terrible on the leaderboard because the first one was really easy. And the second one was probably not as bad as I would have thought. I bet you if I had done better on the first question, I could have actually gotten a much better rank. The first part's what killed me. Either way. Anyways, let's go over how I did day 10. So, for part 1, basically the question is we are given this big long input of integers. Their question or their story kind of confused me. It's better just to think that, just better think of the rules. The rules are you're given this big long thing of integers. You're starting at 0 and you're going to your highest plus 3. What you need to do is the first part is asking in the string of integers, how many differences of 1 are between each index, how many differences of 1 are there, and how many differences of 3 are there. And so you go through your list, you basically check your index. If you check, well, this assorted, we sort this as well. So an assorted version of this, we check an index and the index minus 1, and we say, how far apart are you? If you are 1 apart, we increment our difference of 1. If you're 3 apart, we increment our difference of 3. At the very end, we just return the multiplication of those two together. For part 2 now, it's asking how many different arrangements can you make to go from 0 to your maximum. And the arrangements vary because 2 numbers can connect together if they are within 3 of each other. So that's where you get into arrangements. We do a big, giant recursive loop. Basically, we start with an arrangement of 0. When we get down, as we recurse down through our trees, when we get to a input size of 1, so basically we're at the very end, we return that the arrangement, you can only make one arrangement out of 1, so we return that up, and then those add together and get to the very top. The way we do this internally though, we have a cache for those. I'll talk about the cache in a second. So the only tricky bit here is this while loop. Because we need our arrangements, we need to know where to branch from. This while loop controls that branching. Basically, we start at the current index and current number, so because as we recurse through, we are removing things out of our list. We start at 0 of our list, the first index, and we pull that out as our current. And then we start our index that we're kind of going up on at 1, so the one above it, and we say, all right, while that number at the index is within, or it's less than 4 away, so it's either 1 different, 2 different, or 3 different, you need to make your recursive call into this to get the arrangements of that. So you could get to the sense to where you might have like the numbers 1, 2, 3, and 4 all in a row. So if you're at 1, you would go 1, okay, and then our next number is 2. 2 is only 1 away from 1, so now we remove 1, and our list is now just 2, 3, 4, and we get the arrangements of this. But we're not done there because 1 and 3 are 2 away, so we need to then remove 1 and 2 and get the arrangements of 3 and 4. And then similarly, 1 and 4 are 3 away, so we didn't get the arrangements of just 4. That's where you're kind of getting this tree-like effect. It's a little hard for me to explain. Their question did an okay job of it, but it's a little bit of a tricky one for me to explain. But anyways, so problem with that though is this recursive loop with how many entries? 96. That recursive loop gets really big really fast because it is going to be like 96 to like towards like the 3rd power. Is that even right? Is it 96 is the 3rd power? Let me just calculate real quick. Is it 96 times 96? No, that's not even right. No, it's gonna be like 96 factorial or something like that. Oh, that's not 96 factorial. I think it's closer to that. Like maximum. I don't quite know there, but anyways, so to improve our runtime, we implement this cache, and basically what this cache means is as we collect arrangements of the array here, basically once you do part of this tree, once you say you get the last 4, once you get to collect all the total arrangements of the last 4 indices, those 4 indices you can't get any more. So we can cache those 4 indices, say, hey, whenever we get these 4 indices as a list, this is how many arrangements you can get from them. And so then eventually it keeps going, it starts from 1, goes to 2, goes to 3, goes to 4, and eventually just keep building up the list backwards and slowly building up your cache to then when you get to the very top, you're only asking for the cache and you're getting it right back. So that improved our time a lot, by a lot more than I thought it was going to, but at any rate, so I'm sorry that this explanation probably wasn't the best. This question was a little harder for me to explain, mainly because their story didn't make a ton of sense to me. I mean, I get it in the end what they're asking, but their story was kind of confusing. And then just the way, I mean, I'm not sure if I blame them because I'm having a hard time creating a story around this. So, but anyways, hope you guys enjoyed. If I rambled on for long enough, hope you guys enjoyed. That's day 10. I'll see you guys all tomorrow for day 11. Peace out.